Hi everyone, I'm Stepan. I work in SumUp. I'm responsible for platform engineering there. Today I will be talking about our OpenID Connect infrastructure and what we did with Hydra and how we actually use Terraform for many things. So what SumUp does is we have acquiring these card terminals, and probably if you live in Europe or US or maybe Brazil or Argentina, you've seen people in coffee shops using our terminals to accept payments. And we're kind of famous for low fees and being accessible even in very far regions in the world. We also do banking, accounting, invoicing, online stores like Shopify-like experience. We also provide developer APIs if you want to accept online payments. So the agenda of this meeting is me talking about a few things. First thing is basically our legacy and the Auth2 server we built ourselves. Then I will be talking about the SSO we built with Hydra and OpenID Connect. I will be also talking, and this will be a primary topic, about how do you self-service your Hydra resources using Terraform, and also talking about tips and tricks you can leverage when following the same approach. So our legacy is our own OAuth2 server, and we kind of used resource owner password credentials runtime, which is thankfully deprecated. Some partners use token exchange to actually impersonate and delegate access. And third-party apps use authorization code flow or client credentials. So it's like kind of mix of grant types, and you probably will not find a solution which actually has them all out of box, even Hydra. And authorization is done via token introspection because tokens were opaque, meaning that you have to call an API to actually know who is a subject of this token. So the problem at SumUp we have is that authentication was inherently decentralized. We had like many login pages. This means that you have multiple entry points to protect, and resource owner password credential grant is just insecure and deprecated. You can't use it anymore because it means that your applications, your clients which integrate with you kind of in possession of credentials. It is just difficult to make changes when many people have their own implementation of authentication. And another problem is just there was no shared session between apps, so sharing happens either through re-authenticating the user or through sharing access tokens, which is not very secure, but there are secure ways to do that. But of course, there are just better ways to do that. So on the right, you can see, for example, two of our login pages we have. There are more of them, which is an example. Another problem is authorization. Authorization in SumUp is centralized, so as tokens are opaque, you have to verify them by the central API gateway and put your services behind it if you don't want to do it in every service. And it introduces the notion of trust, meaning that you have to ensure that traffic only goes through designated gateways to prevent side attacks. So services kind of trust their downstream. To solve this, we leveraged Hydra to switch to OpenID Connect and build our own SSO, and authentication now is centralized. So we have single login and sign up pages to protect. All users use just auth code flow with PKCD, meaning that it's secure enough even for public clients. We can leverage ID tokens to carry profile data, for example, your email or profile picture. And we also can trigger MFA via ACR values. ACR stands for Authentication Cost Reference, means that during authentication, you can request which security level you want to have when you're authenticating the user. Means that it can be more than username and password. Yeah, on the right, you can see our iOS implementation of SSO. And those are login and create account pages. And authorization can be decentralized now because our access tokens issued by Hydra are JWT, meaning that you just need to share the same key set across clients to verify the tokens, and they don't have to be in SumUp anymore. So you can have a partner which just points to our public JWTs, and verify the token. And there is no trust anymore. You can always verify the token yourself. Even if your downstream API gateway already did this, you can check the token again. The Hydra deployment is quite simple. It's a highly available Kubernetes deployment. We run in AWS EKS. It's managed by JSON, Net, and Grafana Tanka. And this is a good alternative to Helm in the sense that it's just more flexible and it's just less template, and you can actually write code when bootstrapping your Kubernetes deployment. The Hydra backed by Postgres, it's AWS RDS running, and it's protected by Cloudflare. The good thing about Cloudflare is that we recently got a lot of attacks against our public endpoints related to authentication, and we leverage Cloudflare to protect them all. And it also used to cache well-known endpoints. So for example, the JWKS key set to verify the tokens is not distributed by us, but by Cloudflare. And funny thing, we run fork of Hydra. We have per client token TTLs, which is feature is not available in the upstream. It allows us to have different clients with different security guarantees. So for example, mobile clients are a bit more secure when storing access and refresh tokens. So you kind of can set refresh token to have higher TTL to avoid user to re-log into SSO session to obtain tokens. And we don't have SSO enabled on mobile devices for reasons. And this just allows us to have different TTL on web public clients, on clients which use client credentials, grant type, and mobile apps. We also have implemented the spec for prompt create. It allows us to trigger registration instead of authentication when you use Hydra. So you can just pass prompt create and they'll render create account page for you. So it's kind of seamless for clients that they can just choose what to do with the user depending on the flow. Because if this is a landing page where you want to sell a card reader, you don't want to authenticate. You want to create an account and let user authenticate if they want just by switching between two prompts. We implemented a bunch of things which are actually now in upstream, but initially they were running in our fork, and this is like features like refresh token reuse detection, where you can detect that refresh token was used twice. And if it happens, then the whole token chain gets invalidated. We also use refresh token hook feature in Hydra, and this allows you to basically get fresh claims on every token refresh. And because our infrastructure runs in such a way that we have just like our own Ingress infrastructure, we don't need TLS enabled on the admin API. We just can protect it ourselves with a proxy. And there is other quality of life changes to this migration. Authentication app we run, the constant app in terms of Ory Hydra is a mix of Golang and TypeScript, and we run on Next.js frontend. So the migration to Hydra was kind of tough because we have too many clients and we don't want to provide them direct access to admin API to self-service creation of accounts of clients, and there is still no public endpoint for dynamic client provisioning registration. So we just had to do something about this because we don't want to provide access, and at the same time we want teams to be able to self-service. And we had to migrate everyone from password credentials to auth code flow. And now the problem is our native apps and SDKs. And because our partners run SDKs which use SumUp infrastructure, we have to show them SSO in the browser instead of having a native view. And I think this was a breaking change on the mobile, because now they have to, instead of showing native flow, they have to show this popping browser. And we have to support different grant types, and some of them are not supported by Hydra. For example, token exchange, where you want to impersonate or delegate the token. And in this case, we had to, again, to add this to our fork. And I hope that Hydra will get support for token exchange soon, so we can just migrate all that. And all of these clients have different token authentication methods. It means that some pass client credentials through authorization headers, some pass them in the payload. Some just don't have them, like public clients which don't have any token authentication method. So you have to consider that. So idea is that because we are kind of fans of Terraform, we can basically Terraform almost everything. And there is a big misconception that Terraform is about cloud infrastructure, but it's not. You can also manage any resources with CRUD, like create, read, update, delete lifecycle with Terraform if you have a provider for that. And you could do it in GitOps fashion. Andreas, during the first session, mentioned that already, how you can do that. We actually do exactly the same. And if you look at that session, we have exactly the same infrastructure. So when we use Terraform, resource can be modified, like OAuth to client or anything else can be modified through pull request. A change can be planned, change can be tested, it can be applied. And if we mess something up, we can always roll back. And it's all captured in our Git mono repo. But you can Terraform almost everything except frequently changing things. I think that never worked well when people use Terraform to release applications. Like, don't put your Helm releases, for example, or anything else into Terraform. It just doesn't work in the long term. So how we manage Hydra resources with Terraform? So we've written our own Terraform provider for Hydra. It has just two resources. First resource is just like OAuth to client, and it allows you to provision OAuth to clients. And secondly is JWS. I think one of the neglected features of Hydra is that you can actually use Hydra as PKI infrastructure to maintain private public key pairs in JWS format and use that for example, applications which have to do encryption or signing. You can just point them to Hydra, distributing the keys. There is a CRD alternative for Kubernetes. CRD stands for Custom Resource Definition, which allows you to manage Hydra resources through custom resources on Kubernetes, but it doesn't integrate well with anything which is not Kubernetes. And templating is as a way to reuse code doesn't work well. So how do you actually Terraform OAuth to clients? So here is an example where I can, for example, create a client with specific redirect URIs and scopes, which has a client secret post token endpoint authentication method. And when I will create this resource, I can, for example, point its client ID and client secret to be saved in our vault. Means that the actual consumer of the client can, after that, read it from vault. This is very convenient because you can have like uniform way of how you provision clients on the on Hydra and distribute their client credentials. So if you're familiar with Terraform, this is quite simple example. I have more docs on that in GitHub repository. If you're a Kubernetes fan, you can of course provision a Kubernetes secret instead of vault. It will work the same way. And about JWS. Yeah, as I said, you can use Hydra as PKI infrastructure serving your keys. And the biggest topic when you have PKI infrastructure, how do you actually rotate keys? If you noticed, recently Terraform introduced time provider. And you can, for example, say that I want to rotate keys every 30 days. And I can use this as a keeper in my JWS resource. And what it will mean that it will generate key once, but every time the keepers change, and keepers are just arbitrary key values, I can regenerate my key set. And this is very convenient because I don't have to think about talking about key rotation. I can just declare how often I want them to rotate. So tips and tricks. What do you do with all of this? My advice, if you use Terraform provider for Hydra, you actually generate client credentials yourself. So like it can happen that if you rely on something like this, Hydra will actually generate a client secret for you if your token endpoint auth method is something else but none. Here, you can always expect that your client ID and client secret will stay the same even if someone changed client secret directly in Hydra. Because if someone done that and you would rely on Hydra generating your client secret, in this case, you wouldn't even notice it and it would propagate to all downstream systems, upstream systems, and it would still work, but your client secret will be different. So my advice to keep it consistent, generate it yourself. I think one of the hidden features of Hydra clients is that you can actually use client metadata to customize behavior. And I think 4 things we use at SumUp are: we have a metadata key for default granted scopes. Sometimes if you have a migration pattern where your client got some scopes by default in a previous system, and client didn't need to request the scope explicitly, to avoid clients explicitly requesting scopes they didn't request before, we introduced the notion of default granted scopes. So for example, you can say here that I want profile scope by default. For example, for first-party and third-party clients, the behavior of constant can be different, because when the client application is first-party, means that it's from SumUp, we don't actually need to show constant screen to the user, and we have control over constant screen through skip constant parameter. Another thing is that we can skip the session. Forcing user to always log in means that even if user requested max age parameter to have a session, or the prompt was not to login, like to actually disable the session. And this is particularly useful for mobile clients where we don't want session to be shared across mobile apps and like Safari or Chrome browsers. We can disable session completely. And relevant setting is which we have just like session max age. If user didn't specify the max age of the session, we want to control it per client. And like if you have any custom behavior you want to do per client, use metadata for that. It's convenient. You can have a schema and it just works. And if you work with that and you kind of reach some limit of clients or resources, I would advise to start moving stuff to modules, meaning that you can, for example, extract your client-related logic to a module for Terraform code, for example, OAuth to client, and that will hide all this complexity, and this will hide the knowledge about existence of the Hydra at all. Like the actual user of your Terraform module doesn't care if you run Hydra or if you run like Keycloak. I run some OpenID connects or off to server. So you can hide your implementation in modules, and user of your Terraform module can say, I want a public client. And after that, I want to get this client ID and output it. Or I want to have a secret client, this client secret basic token endpoint authentication method. So what I like about Terraform is that even though it's very stupid and simple, it still gives you enough abstraction to make it easier to work with resources. So yeah, that's kind of it. You can reach me out on LinkedIn or just find my projects on GitHub. and you can find the Terraform provider for Hydra there. And you can also check out the OpenID configuration for SumUp. It's publicly available, and you can check how we set it up. Yep. So now questions.
So thank you, Stepan. We're going to have maybe 1 or 2 questions. We still have a few more minutes. And we have, I think, a question around your fork of Hydra. How are you maintaining that, and how are you bringing that and keeping the integration with the main Hydra branch?
Yeah, so our fork is like, it's a sub-module in our monorepo, and we have our own CI pipeline for that. And we just we keep our patches pretty simple and non-conflicting, that we are just able to merge up, like, or even rebase on upstream and just squash all our patches on top of current upstream. And because we run the same integration test suite as Ory does, we ensure that nothing breaks, and we are still conformant to OpenID Connect specification.
Okay, there was another question about the setup. Do you have a local regional distribution, or is it globally distributed, or how does your system architecture work?
So this is purely, like, this is hidden from deployment, but just like our Kubernetes infrastructure is distributed, and we just, our pods of Hydra are just distributed the same way as every other cross-region deployment. So yeah,
okay.
That's kind of, it kind of depends.
Stepan, thank you very much for your talk. There's going to be probably some continued discussion on Slack. So if you have some time, you can please participate in that. And with that, we'd like to end this session. And thank you very much for being a speaker and for being an active member of the Ory community. We love having your ideas and your input. So look forward to working with you again soon.
Yeah, thank you very much. See you.